So the idea is this spaceship will be cylindrical in shape, has a large cylindrical cave or bore, such as a Holland tunnel, size of that or more in diameter. And it will basically be annular, and by annular, I hope annular means that there are two walls with space between the walls. And these wall can move along the length of each other to a certain degree and rotate about a central point to the radius or center of the circle that determine these cylinders one within the other, which I think is what annular means. So the reason it has two walls is so that the two walls can interact to provide velocity forward and to provide angular momentum radially. Now the engines would be inside the inner cylinder and will be virtually or physically mated to both walls somehow without interfering their free movement. And then the idea is to use the recoil and forward velocity or pushing pulling kind of force to speed it up in the far direction and to rotate it about the center to steer it. Whether that works or not, I don't know, but I think it should. Because in space, the only thing you have is action and reaction. You don't have friction. The friction is all internal. You need external friction to change direction or velocity in the classical case. This is not a classical case. This is interstellar space, where it's basically pragmatically a vacuum. Now, force is equal to mass times acceleration. The acceleration due to gravity on Earth is 10 meters per second square. So on Earth, if you have a mass of 1 kilogram, the force in Newton that weight will exert down to the center of the Earth is 1 kilogram 10 times 10 meters per second square, which is 10 newtons. I made some errors in calculation and in units. I have no notes. I'm making it up as I'm saying it. Of course, I mulled it a bit, but it wasn't planned or rehearsed. I mulled it in my mind, not consistently, but over a period of time now and then.